Hello. Hello.
Yes,
Can you hear me?
yeah,
Uh,
You're audible now.
yeah, okay, fine. And can you see my screen? Okay. So we will start with today's session. And before that, is there someone who was not there in the previous session? Do we have some new people, or is it like everyone was present in the last session?
Yes, ma'am.
Okay, fine. So it seems everyone was present in the last session. So everyone has the YouTube link and the Google Drive link, I suppose. If not, I would still just put it up over here right now. Just give me a minute. I was not present in the last session. So AU, could you please let me know your name from AU? I don't think I understand much. If you could rename your icon over there. Okay, so AU, I have put Rakesh Kumar Jha. So Rakesh, I have put the YouTube link in the chat box. If you can check that. So this is the YouTube link where you would find the recordings of all the sessions that we are having. And apart from that, we have a Google Drive. So where I would be uploading all the notes. So I will put the link to the Google Drive as well. So here is the link of the Google Drive. And we also have a Discord server. So I'll send the link of the Discord server also to you. So we have a Discord server where participants can join and pose questions that they might have and some queries or anything. So I'll just give you the Discord link as well. So you can go ahead and check out the YouTube video as well as the Google Drive and this Discord server. So anyway, last class was just introducing students and introducing myself. So you did not miss any problem solving sessions per se. So we will start with the actual problem solving sessions from today. So that's the plan. So you can, so Rakesh, I think you have got all the links right now, right? Could you just give me a thumbs up or say yes somewhere? Yeah, okay, fine. So even for other people who did not have the links or for whatsoever reason, I've put all the relevant links over here. So this is the Zoom Meet link that you would be joining for the sessions. And sessions are every Saturday 1:30 p.m. for 1 hour. And then there's the YouTube channel which you can go ahead and subscribe. And then there is Google Drive, so bookmark it in your browser so you can go to the Google Drive for the notes. And then we have the Discord server, so do bookmark all of these and join all these channels that we have. So the thing is that we would be focusing on four main topics in the GATE physics examination. So first one being general aptitude, then mathematical physics, then electromagnetic theory and quantum mechanics. And since today is our first session, on the problem solving part of it. Last class we just did introducing ourselves. So since today is the first problem solving session, what I have planned for today is I will take one problem from each of those four topics just to give you a flavor of the kind of stuff that we would be discussing in these sessions. So one question from each of these four topics for today, and then from next class onwards we will pick up one of these topics and we will focus on that topic for the entire 1 hour lecture. So let's say if we pick up mathematical physics, we will solve mathematical physics questions in that 1 hour and maybe a few general aptitude. Next day we would do electromagnetic theory and then quantum mechanics and like that. So, but today we will start with looking at one question each from each of the four topics. So we begin with something very simple just to start and just to get started and just to get into this mode of solving the problems. So first question is from general aptitude and it is an English based question. So you need to know basic English. So you should have some basic knowledge about English as well in order to solve the GATE physics examination. So the first question says in general aptitude, which of the following options is the closest in meaning to the word below, circuitous? So we want to find out which of these four words is closest in meaning to the word circuitous. These questions, by the way, before we proceed, are from previous year's GATE physics papers. So I have previous years 2010 up until 2022. These 12 years GATE papers I have. So I would be taking questions from these 12 years GATE physics papers and we will solve them in these sessions. So this one is a very simple one. So the closest in meaning to circuitous is indirect. And for those of you who don't know the meaning of circuitous, I have the meaning from Oxford Advanced Learners Dictionary. So for English, I would suggest that you people refer to Oxford Advanced Learners Dictionary or even Cambridge Dictionary. These are the two standard dictionaries that we have. So if you go to Oxford Advanced Learners Dictionary, then the meaning of circuitous is given as follows. So it says that circuitous is a word that you would be used to describe a journey or a route which is long and not direct. So not direct means indirect. And a synonym of this is roundabout. So instead of circuitous, if they had given roundabout, you would still select indirect. And one example sentence. So this is one example sentence. He took us on a circuitous route to the hotel, meaning a long and indirect way. Means there is a shorter direct way to going to some place, but someone is taking a long and indirect way to reach the destination. So that says what circuitous is. So this is the use of the word circuitous. So fairly simple. So you need to, there are quite a few questions based on English words and fill in the blanks for some English sentences. So you should be having basic knowledge of English grammar and English vocabulary. Next, we move to mathematical physics. So here we are given a matrix. So I hope nobody has any query, right, in this part. So we move ahead. So the next question is from mathematical physics, which says that we are supposed to find out the eigenvalues of a given matrix. So let us start. Again, this is quite a simple question. You people can do it side by side as I'm doing this question. So fairly simple question. So today we will start with fairly simple questions just to build up a base so that we can proceed to much more complicated questions later on. So the eigenvalue equation is given as follows, where A is the given square matrix and lambda is the eigenvalue and x is the eigenvector. So I hope you're able to see my screen, right?
Hello,
Yeah, someone is saying something.
ma'am. It's kind of blurred out.
It's blurred out. Okay, let me check. Not much clear. Yeah, even I am not able to understand why this is happening. Just give me a second. Okay, is everyone not able to see it properly, or is there someone who can see it properly? I think this was not an issue last time round. Could someone send me a screenshot of what you are seeing in the Discord server? Like, I'm not able to understand what you people are seeing, right? So could someone just send me a screenshot? Yeah, Rakesh, I understand people are finding it blurred, but could someone just send me a screenshot of what you are exactly seeing so that I can try and fix something? If quickly someone can do that. Okay. Seems like Zoom is a problem, right? YouTube seems to be fine. Okay, if people are finding things blurred on Zoom, I would suggest that people log in to the YouTube. On YouTube, I'm checking, it seems to be fine. Like, YouTube is not at all blurred, it is clear. Maybe Zoom is doing something funny out here. So, anyway, we'll proceed. So, people, I would suggest that you log into YouTube as well, on a separate device, maybe, or something. So let us proceed. So we have the eigenvalue equation written down out here, where A is a given square matrix that we have, and lambda is the eigenvalue, and x is the corresponding eigenvector to the eigenvalue lambda of the square matrix A. Now, solution to this,
Ma'am,
yes.
could you please read out the elements in the matrix?
Yeah, I would suggest you to log in to YouTube. There it is clear.
Oh, okay, ma'am.
Yeah, so you could log into YouTube and mute either one of them, mute either Zoom or mute YouTube. So you will be able to see the text from YouTube, and then you can see the what I'm saying and what I'm speaking maybe from Zoom. Or either way, means either you could log in solely through YouTube or solely through Zoom, or you could just log out of the audio from Zoom, so that if you have some question you can put it in the chat box and then you can watch through YouTube. I'm not able to figure out why today Zoom is not working out fine, but YouTube is working fine. So yeah, please log in through that. So solution to this would be a minus lambda I x is equal to 0. And in order to solve this, we need to set the determinant of a minus lambda I to be equal to 0 in order to get non-zero eigenvector x. And why do I say so? I say because if, let us say, if a minus lambda I, this determinant, is not equal to 0, then the matrix A minus lambda I is invertible. So if you have non-zero determinant, that means that the matrix is invertible. And if it is invertible, then from the equation that we have, we can invert this matrix, and then we will get x equal to a minus lambda I inverse times 0, which is 0. But we do not want a 0 eigenvector. We want non-zero. So for non-zero x, you need to set determinant of a minus lambda I to be equal to 0. Now in our case, what is our A? A is given as the following matrix: 2, 3, 0, 3, 2, 0, and 0, 0, 1. So this is the matrix that we have. So now if you write down A minus lambda I, that would be 2 minus lambda, 3, 0, 3, 2 minus lambda, 0, 0, 0, 1 minus lambda. So this is the determinant that we need to find and set equal to 0. So this is our A minus lambda I determinant. So this gives me, I'm just expanding along the first row. So 2 minus lambda, 2 minus lambda, 1 minus lambda. Now from this element, now just simplify this. Take 1 minus lambda common. So this is just plain simple algebra. So I will factorize these terms over here. And now we get all the terms factored out. So the solution to this is then lambda is equal to 1, 5, and negative 1. So we have these three eigenvalues. So coming back, the correct option is option number C, where eigenvalues are 5, 1, and negative 1. So this is a simple question on finding out the eigenvalues. Now, before proceeding, I would like to list down certain properties for eigenvalues so that you can use these tricks and properties to solve the questions maybe faster. So the properties that I'm going to list down is that if you have a diagonal matrix, or even more generally, not just diagonal, if you have any triangular matrix, so to say, not just diagonal is just a special version of triangular matrix. So if you have any general triangular matrix, upper triangular or lower triangular, then the eigenvalues of a triangular matrix are simply the diagonal elements. Meaning if I have a matrix, let us say, if I have a square matrix, and if it is a triangular matrix, let's say upper triangular, let us say, so the bottom triangle elements are 0, then you have some elements out here. This cross means that these are some elements and these bottom triangular elements are 0. In such a case, your eigenvalues are this diagonal elements. These three elements out here are the eigenvalues. So you need not actually compute the determinant to find out the eigenvalues. If you have a triangular matrix, you just read out the diagonal elements and they are your eigenvalues. Some other properties are that determinant of a matrix is the product of its eigenvalues. Trace of a matrix is sum of its eigenvalues. And then if we have a unitary matrix, so unitary matrix, then the modulus of each of its eigenvalue is going to be equal to 1. So this is a property of unitary matrix. So if you feel that, if you see that there's a unitary matrix, then for unitary matrix, all your eigenvalues will have the modulus equal to 1. And then last property that I want to list down. By the way, for those of you who have forgotten, unitary matrix is given as follows. So this dagger right here is the basically Hermitian adjoint. So that means you take the complex conjugate and then the transpose. So this thing right here is basically you take complex conjugate and the transpose. And coming to the last property, so eigenvalues of the matrix A to the power k are given by lambda I to the power k, where lambda I are the eigenvalues of the matrix A. So if you have eigenvalues of a matrix A and you want to find out the eigenvalues of certain powers of A, then you just need to take the eigenvalues of A and multiply it as many times as the power. Next, we proceed to a question on electromagnetic theory. So here is a question. This one question is also pretty much simple. So this question from electromagnetic theory says that consider the propagation of electromagnetic waves in a linear, homogeneous and isotropic material medium with electric permittivity epsilon and magnetic permeability mu. So for a plane wave of angular frequency omega and propagation vector k propagating in the medium, Maxwell's equations reduce to one of these four options. So k dot E, k dot H, k cross E and k cross H we need to find out, and then one of these four options right here would be correct. So before proceeding, let us write down our Maxwell's equations for a medium. So we have Maxwell's equations. So first equation is del dot D, then next equation is for del dot B, which is equal to 0. Then we have curl of E and how it's related to the time derivative of magnetic field, and then curl of H and its relation to the time derivative of electric field. So now for the medium, we have this electric displacement vector D written as epsilon times E, and B is mu times H. Now, why these relations are true? This is true only for a linear medium, and we are given that we have a linear medium right here. So this is a linear medium. And you can write, since it is plane waves, so we have plane waves. So in that case, we have electric field given as some amplitude times the e to the power I k dot r minus omega t. Then similarly for the magnetic field, and from B and H the relation is there, and you will see that we can also write H as follows. So these are the expressions for the plane waves of angular frequency omega and propagation vector k that is given to us. Now we can write each of these amplitudes, this E naught, in terms of components like E naught x along the x cap direction, E naught y along the y cap direction, and E naught z along, sorry, this z should be in the subscript, E naught z along the z cap direction. Similarly, you will have a component. You can write down the components for B naught, for H naught. You can write down in terms of components for along x cap, y cap, and z cap. The k vector, also it will be kx along x cap, ky along y cap, kz along z cap, and the r vector is going to be as follows. And hence our k dot r is going to be like so. So this is the k dot r that we have. And now we will look at each of these four Maxwell's equations, and we will try and plug in these expressions for E and B, and then see which of these options turn out to be the correct ones. So you can see that k dot E and k dot H is 0 in all of these options. So we do not necessarily need to check them. So because it's an MCQ question and it is time bound MCQ question, you need not start by checking k dot E and k dot H. You could simply start by working out k cross E and k cross H, because that is going to give you the answer. But for the case of understanding and for the case of understanding the concepts, I will solve each of these four Maxwell's, basically I'll plug in each of these expressions for E and B in the four Maxwell's equations that we have, so that you understand exactly what is going on. So let us start with the first Maxwell's equation. So first Maxwell's equation is del dot D is equal to 0. Why? Because the charge distribution, the free charge distribution that we have in our case is 0. So let us now basically plug in these expressions that we have written down. So del dot D equal to 0, and D is nothing but epsilon E. So this is equal to 0, and we can take this epsilon out. So epsilon del dot E is equal to 0. And why can we take it out? Is because we are given that we have a homogeneous medium. So we are told that it's a homogeneous medium, homogeneous isotropic medium. That means this epsilon is not a function of the spatial distribution, the spatial location. So epsilon is a constant all throughout the medium. That is what it means. So let us proceed now. So this means that del dot E is equal to 0. Okay, so this is what we have, and let us now just plug in this expression for E that we have written down. So this means that 0 is equal to del by del x, E naught x e to the power I k dot r minus omega t plus del by del y E naught y e to the power I k dot r minus omega t Similarly, del by del z minus omega t. So this is what we have, and we need to basically expand this and find out the derivative. So it is pretty simple. So you would see that del by del x of this. So let me actually first expand the k dot r term for you. So k dot r is nothing but kxx plus kyy plus kzz minus omega t. So I'm just expanding this k dot r term everywhere. Now you see that del by del x, look at this first term. So when you differentiate with respect to x, you get ikx term outside. So what you get is e naught x is a constant and ikx is what comes out from the derivative, and then rest of it is as it is. Similarly, over here, what will come out is I times ky, and e naught y is a constant. And similarly for the last term. Now you notice that this big expression is nothing but I times k dot e. So why I say that? See, I you can take common from each of these three terms, and the remaining term is nothing but k dot e. Kx times e naught x, and this exponential term is same for all. Ky times e naught y, and this exponential term. Kz times e naught z, and the exponential term. So this is nothing but k dot e, and this I term is there in all of them. So what you get is del dot e is equal to I k dot e, which is equal to 0, which implies that k dot e is equal to 0. So from the first equation, we get k dot e is equal to 0. Now we will focus on the second term. So similar to how we focused on the first Maxwell's equation, similarly we will focus on the second Maxwell's equation. So next, so we will start by this. So now you see that we had written that B is nothing but mu times H. So del dot B is nothing but del dot mu H, which is equal to 0. And again, we can take mu outside. And why we took it outside? Same reason. this being a homogeneous medium. So this is a homogeneous medium. That's why we can take mu common outside. And so let us just solve it similar to how we did for the previous equation. So similar process we are adopting over here. What we did with the electric field, we are doing the same thing with magnetic field this time. And again, you can see that I can expand it for you. So h naught x e to the power I kx x plus ky y plus kz z minus omega t. And similar for the other terms, I will not write down the other terms. You can write it down yourself. So similarly, it's just expanding this exponential term. So again, now when you take the derivative with respect to x, what you get? You get this I kx term outside. So h naught x is a constant, then I kx and e to the power I kxx plus ky y plus kz z minus omega t. And similarly, you have for the other terms, this time it will be I k y which comes out, and then the exponential, and similarly for the z and the exponential. Exponential is same throughout. Now what you would notice is this is nothing but I k dot h, just like it was I k dot e in the previous case. This time around it is I k dot h. So what we get is del dot b is equal to I k dot h, which is equal to 0, which implies k dot h is equal to 0. So indeed, in the options that you see, all of them have k dot e is equal to 0 and k dot h is equal to 0. So that means everything is consistent and correct. Now we will look at the third Maxwell's equation. So del cross E is equal to minus del B by del D. Now, if you remember how to find out the curl, it is, we write this big determinant out here. So x cap and del by del x, and then E naught x e to the power I kxx plus kyy plus kzz minus omega t. Then you have y cap del by del y e naught y and same exponential. Then you have z cap del by del z e naught z and the same exponential. I'm not writing the exponential again and again, so you can just copy and write down the same exponential again. So expanding this determinant, what you get is first term x cap. So del by del y e naught z e to the power I kxx plus ky y plus kzz minus omega t minus del by del z e dot y e to the power I kx x plus ky y plus kz z minus omega t. Then minus y cap. So this is the determinant. So you have first x cap and then these terms, then you will have minus y cap, and then you would take del by del x of e naught z e to the power I kxx plus ky y plus kz z minus omega t, and then minus del by del z of e naught x e to the power I kxx plus ky y plus kz z minus omega t. And finally, you have the last term, which is with z cap. So this is the expansion of the determinant to find curl of E. And you can find out these derivatives. They are pretty simple. So for the first case, what comes out is I times ky. This is del by del y. So what comes, and E naught z is constant. So what you get is E naught z, I times ky, and exponential I kxx plus ky y plus kz minus omega t. And from the second, what comes out is kz, ikz comes out. So you have minus e naught y ikz, and the same exponential. I'll not write it again. So same exponential. Then minus y cap e naught z, this time ikx comes out because it is del by del x. So ikx will come out. And then the exponential. Then you have e naught x I k z, and the same exponential. Finally, for z cap term, now if you notice that these terms, you take I common out, and what remains inside is nothing but k cross e. You can write down this determinant for k cross e, how you would have. So k cross e, here you would have kx, ky, kz, and the last row would be the same. And if you work that out, you would realize that this expression right here, this thing right here, is nothing but k cross e times I. So this is what you get for curl of E. And for the right hand side of this equation, we have minus del B by del T. So if we work that out, this is minus del by del T of B naught e to the power I k dot R minus omega T, which is nothing but this time minus I omega will come out. So you have minus I omega coming out. B naught e to the power I k dot R minus omega T, which is nothing but I omega B. So what you have from the third Maxwell's equation is del cross E is equal to minus del B by del T. This means, and del cross E is nothing but I k cross E. That means I k cross E is equal to, and minus del B by del T is this I omega B. Oh, sorry. Yeah, sorry. this is not minus, this is plus only. I said minus. If I said minus, this is plus. So I k cross E is I omega B, and cancelling out I from both the sides, you get k cross E is equal to omega B, and B is nothing but mu times H. So you get the following: k cross E is equal to omega mu H. So this is from the third Maxwell's equation. Now, similar thing you would do with the fourth Maxwell's equation. This time we have curl of H instead of curl of E. And why this? Because the free current is 0, so JF is equal to 0. And I can write down the determinant form for finding out this curl, pretty much similar to what I did for curl of E. So you have x cap del by del x h naught x e to the power I kxx plus ky y plus kz z minus omega t, then y cap del by del y, same exponential term, and then z cap h naught z, same exponential term. And you can expand this determinant just like we did previously. So let me quickly do it right here. So x cap del by del y h naught z, and then the exponential I kxx plus kyy. So this is for x cap, then negative y cap. Same exponential term again. And finally, z cap term. And similarly, you can just find out, you can just get these derivatives. These are pretty much simple, just like we have seen. So you would have I ky coming out from here, I kz coming out from here. So I would just quickly write it down. Then the exponential term. Then minus y cap. And then z cap. So similar to the previous Maxwell's equation, you would notice that this is nothing but I times k cross h. I is common all throughout in all these terms, and the remaining part is k cross h. So the right hand side of the fourth Maxwell's equation is del d by del t. And quickly, if we find that out, d is nothing but epsilon e, and epsilon is constant taken outside. So what comes out from the time derivative would be minus I omega. So epsilon minus I omega, and the remaining stuff is as it is. So this is nothing but minus I omega epsilon E. So what you get is del cross H is equal to del D by del T. And del cross H we found is IK cross H. So this solves the question, and if you go back to the options, going back to the options, you would see that option number D is the correct option, where K cross E is omega mu H and K cross H is equal to minus omega epsilon E. So instead of doing all this big algebra, I have a small trick for you. A trick which can basically be used to arrive at all of these expressions in a faster, quicker manner. So I'll write down the trick for you so you can use this trick to solve the question. So the trick is that you replace your curl or gradient, basically this del operator, by the vector ik, and you replace the time derivative by minus I omega. So if you use these, you would see that immediately you would arrive at the expression. So del dot D is equal to 0 implies ik dot D is equal to 0. You get the first expression right away. Del dot B equal to 0 implies ik dot B is equal to 0. Del cross E is equal to minus del B by del T gives you ik cross E is equal to minus, so minus of del B by del T, and del by del T is minus I omega times B. Again, you come at the equation right away. And finally, the last one. So this trick can be used to solve the question faster. But now, since I worked out the maths, you realize that why we can use this trick. So the maths is the real thing. This trick is based on the maths that we have just worked out, the full algebra, the full stuff that we have done. But once you have done that, you can keep this trick in your mind. So after you have solved this entire mathematics, you can keep this trick in mind, and then you can now solve the question much faster. You see, just by using this, I arrived at all these 4 expressions in less than a minute. And finally, one example question from quantum mechanics. Again, a very simple question. It says that the quantum mechanical operator for the momentum of a particle moving in one dimension is given by, so one of these options is correct, and the correct option is B minus IH cross D by dx. So let me just write down the Schrodinger's equation for you. That way you would know all the operators. So Schrodinger's equation is Hamiltonian operator acting on the wave function psi is the following, where this operator is the energy operator. So this IH cross del by del T, this is nothing but the energy operator. And then you have the Hamiltonian operator can be written as kinetic energy operator plus the potential energy operator. So kinetic energy is nothing but P squared by 2m, and potential energy can be written by V, and P is minus IH cross D by dx in one dimension. So this is minus H cross squared by 2m D squared by dx squared plus V. So this operator right here is your basically kinetic energy operator, and this A is nothing, it doesn't represent any significant thing. And if you go in 3D, so 3D, then you would have minus h cross squared by 2m grad squared. So this was just a brief overview of the kind of questions that we would be solving. So I took one example question from each of the four topics: general aptitude, mathematical physics, electromagnetic theory, and quantum mechanics. I do have a few general aptitude questions written down, so we'll do them in the next lecture. So this was just to get you started, that these are the topics that we will focus on and what kind of questions are asked in these topics. And from the next lecture, we would be focusing on one topic. So let's say today, let us say for the next lecture, we can fix up any topic, let's say general aptitude. Then the entire lecture, we would be talking about general aptitude questions. Then the next class, we can discuss mathematical physics, and next class maybe electromagnetic theory, and then quantum mechanics. So this is the kind of plan that I have for the upcoming sessions. So if you people have, ma'am, what if JF in del cross, what about, there's someone who's asking some question, I am not able to understand what this question is. What about JF in del cross H equation? Okay. Yeah, so in our expression, in the case that we are given, JF is 0. We do not have any free current. We do not have any free charge. So JF, rho F, both are 0 for the case. So yeah, so this is the plan for the upcoming lectures, where we would primarily be focusing on one particular topic. Today, just to give you a flavor, just to give you an idea of the type of questions, I took one question each from each of the four topics. So if you have some suggestion, if you have some particular topic in your mind that you would want to address, you could say that right now. So does anyone have any query, any suggestion? And I'm really sorry about the Zoom thing today. It was working fine up until the last time. I don't know what happened this time. So I'll fix it up next time for you. Hopefully it will be fine the next time. So does anyone have any question? If not, then we close the session over here. So if you have some suggestions, you could give it in the Discord server if you want to give some suggestions later on. Yeah, but for today, the session is over. So if someone has some question, you could ask. Else you can ask in the Discord server, and it's all there in the chat box. I've given the link. I'll give the links again if someone does not have it. So this is the Discord server. This is the Google Drive where I will upload today's lecture notes. So I'll upload these lecture notes and you can have a look at them. And this is the YouTube channel which you can go and subscribe. So the main takeaway from today's lesson, I would say, is this trick right here. So you can basically keep this trick in mind every time you are trying to solve some questions. So instead of doing this entire long maths that we have done, simple maths, but still it is time consuming. You see that every time I need to write these exponentials, it is quite time consuming. And instead of that, you can just use this simple trick to solve your MCQ questions much faster. So yeah, thank you everyone. So yeah, if you people don't have any question, you can leave. So Gopal, Divya, So yeah, Gopal, you can leave now. Papul, you have some question? Hi Papul, do you have some question? Papul, if you do not have any question, then you may leave now. We will meet next Saturday.